Good afternoon, gang. This is Tom here. Just wanted to give you a little update on a train automation. When I first started out, I was going to use a reed switch, which is these guys. They were unreliable. So then I got on to getting a Sherlock Detector board with some optical sensors. Let's see if I can get them in focus. That's what they are. And it took me a little while to get this set up. And got the mini panel here. And this is running through a sequence. I just pushed this button here, started the train after a little delay. Because the signal isn't set up with the light on the workbench here. And so what I did was, on the mini panel, you take 8 ports here. This is J5 1 through 8. And you run those green wires to the Sherlock detector, which is J4, which is switch output. And then you have to put them in a proper sequence over here. And that's all in the manual, in this guy's manual here, in the back page. Let's see if I can get that up and show you. That chart there tells you which mini panel goes to which Sherlock detector port. So you just follow them instructions. But the instructions had a little blunder in them, like all instructions do. And in there it said NCE cab bus. Well, what they meant was DCC track power. Okay? So a cab bus is, this is my power cab setup. There's my NCE EDP board, and the cable, this is a cab bus line, and then that goes to a mini panel, from the back to the mini panel, and then to an NCE AIU01. They're all that's a cab bus. So I didn't know how to power the Sherlock detector. Well, we got that all worked out. Took 2 jumpers off of the track power. That's DCC, and we can see that's power. Got lights on. Plus the bumpers are lit up, so I know that the power's on. And then I hooked 2 wires up to it, and then those 2 wires go to this jumper here, which is J1, 1 and 2. And it says DCC1 there and DCC2 there. They get plugged into there. Okay? Then from the Sherlock detector, from jumper J8, port 12, you take this white wire and it goes to the mini panel ground. There's 3 terminal blocks here on the ground. That says GND on there. So now you got power to your Sherlock detector, and it's connected to the mini panel. So then this terminal block you see here, the yellow wire is a ground wire, and you can plug many inputs, grounds, into this terminal block, so it'll all be one common ground. That's off of the mini panel. So you see the little red LED. It's hard to see with the light. There's a red light there, trying to shade the light. That means there's power. Now, I have an optical sensor here in the track, and I have another optical sensor here. Now, when there's light, the optical sensor is off. When I hit my finger, you see that red light come on. Okay? So when the engine, as it's coming back now, it's going to hit that optical sensor. Now it's hit it. Now the red light is lit up on the Sherlock detector, and once the car gets over it, it'll go off. There it is. And now that sent a signal to stop this engine. So he'll stop there in a second, and the light just went from reverse to forward, all automatic. So this engine and this routine's been running for 3 hours now. I started it a couple hours ago, once I finally got it working, and it's been running. And so that's how you set up a mini panel with a Sherlock detector. So again, just to recap, well, I didn't tell you how to set up the sensors. So I soldered wires onto the sensors, and then this here sensor here, see if I put my finger over it, the light comes on, see, off on. So pretty cool. And the two wires, one wire goes to J15, and then it common goes to J21. The second sensor is J26, and its common is J23. J22 is not used. Okay? Now, you see I have a wire here, jumper. That's J27 and J28. Now what that does is it allows the optical sensors to calibrate. So when you put those two wires on J27 and 8, it puts it in the calibration mode. When you turn on the system, the Sherlock says, okay, all sensors, detect how much light's in the room, and it'll correct the sensors for that particular light. And these can run in almost darkness. That's what they say. So we'll see. And so like if I turn out the light right now, that light comes on, right? I turn on the light, it goes off. Okay? So now I can put this up on the layout now and set up this to run. The only problem I had today was the BNSF engine that I was sitting there working, the motor seized. The soundtracks decoder and the speaker and the lights all work great, but it just won't go forward or backwards. The motor doesn't spin at all. So now I need to find another motor for a SW11. I did a little research, couldn't find any. But, you know, because this engine I can use, but it doesn't have any sound. In order to get the horn to play on this type of a decoder, I would have to put in 3 additional lines of code in to play the horn. which is stupid. The Sasami 2, you can set up CVs so it automatically goes when it goes forward and reverse. So I'm looking for a motor to put in. This is an Atherin ready to roll engine. That was DCC ready when it came, and all I did was took out the board in there, put a buddy board in there, put the Sami 2 plug in, and then a Scale Sound Systems speaker, which sounds great. I love it. But unfortunately, the motor doesn't spin anymore. So I know the track power wires are good, because as soon as I put it on a DCC track, the decoder fires up and plays all the sounds. It just doesn't move. So it's strange. I checked the wires on the motor. They weren't touching anything. I don't know. The motor just blew out. It was running last night. I had it running on here, just testing it. And I didn't have the optical sensor set up, but I was just testing the motor. So, very strange how things work one minute and then they don't the next. So, but we got the optical sensors working. Going to set them up on the layout now. And then I'll have the 3 trains on the lower level running and the 2 subway system trains. That's the goal for getting them done by next week. It's going to take a little while getting this all wired up. The sensors, I have to put 6 sensors up on the subway system, 1 for each train station, so it can stop there. This Sherlock board can handle up to 8 optical sensors. So I got an optical sensor on this point-to-point track that I'm putting up there. I have 1 optical sensor for my passenger train on the lower level to stop at the train station there and then continue after that. And then 6 for the subway system, because I have 3 subway stations that it has to stop at each one. So there's the 8 sensors that this board can handle. So I'll be using all 8 of them. So for the 3rd level, I'm going to either have to get another board and some sensors, or some other kind of detection to trigger the train to stop up there. I'm also thinking about maybe trying to use an NCE BD20 hooked up to the track, hook it up to the track, and it'll sense it, and then that can be hooked up to the mini panel. A BD20 can be hooked up to a mini panel. So, and that's just like a sensor. So I can just check when I get a ground signal from the BD20, and then I can send some code to the engine telling it to stop and stuff like that. So that's the next thing to test. I'll get a BD20 and hook it up to this track here and test it. Like, I can put insulator joiners here or here before the turnout, and that'll separate a block and stuff like that. So we'll go from there, but 1 step at a time. So next time you see this train, it'll be running up on the layout. I'm going to put that together tomorrow, and it's a shame that engine died on me, because that's the engine I want to do, because it has the horn and the bell playing, and that's how I know it's still running. So, but you can hear this engine running too, but with all the engines running, the horn and the bell makes it better. So, but that's it, folks. This is Tom. I hope everybody has a great rest of your day, and we'll see you all in the next video. We'll all catch you all later. Take care.